Okay, so this is page 14 in your packet, and today we are looking at solubility curves. So this graph over on the right side is showing solubility curves for potassium nitrate in the red, potassium chloride in the green, and sodium chloride down in the blue. Couple things to notice on here are down on the x-axis is the temperature. Okay, so as we go across, it's getting warmer. And on the y-axis, it's the grams of solute in the solvent. And the solvent here is 100 grams of water. Okay, so obviously these are all aqueous solutions because they're dissolved in water. Now, question number 1 says, what's the solubility of potassium nitrate at 30 degrees Celsius? So we find potassium nitrate on this red line all the way through, and they want it at 30 degrees. So you go down to 30 degrees on the temperature, and you ride that 30 degrees up until you hit potassium nitrate, and then you take it over to the left. It's hard to draw on the iPad. Okay, so it's about 45, and our label is grams. Next one, what's the solubility of KNO3 at 90? You go all the way out to 90 degrees. Take that line all the way up, and you would see that you hit the KNO3 line at, when we go over, that's 200 grams. What's the solubility of KNO3 at 40? Go down to 40 degrees, ride that line up, and you see that that's about 60 grams. So if the solubility of KNO3 is 120 grams per 100 grams of water, what's the temp? Well, they're telling you that they have 120 grams. I'm going to switch my pen color here. 120 grams, which is right here, in the 100 grams of water, and that's just saying this. So what's the temp if it's soluble? And they're talking KNO3. So we take 120 grams, and we go over to the KNO3 line. Once we hit it, then we drop it down, and we see that that's about 65 degrees. Next one, number 5, if 200 grams of KNO3 is dissolved in the 100 grams of water at 80 degrees Celsius. So 80 degrees is right over here. And they're saying that they have 200 grams of KNO3. So we go at 80 degrees and we go all the way up. 200 grams would be up here. What type of solution would that be? Well, the line is down here, and you're telling me that you're putting 200 grams in way up there. So because it's over the solubility line, that means that it's saturated. It can't hold anymore. If 200 grams is dissolved at the 100, then you would see it. This line would keep going up. So 200 at 100 degrees then puts you under that line. So that would be unsaturated. If 150 grams of KNO3 is dissolved in 100 grams of water, okay, let me just quickly erase all of this stuff on here because I'm going to keep marking this graph up. Can you hear Remy snoring again? She's next to me. Pen. Let's go back to red. Okay, if 150 grams of KNO3, so 150 grams is up here, and we know that we're looking at the red one, is dissolved in the 100 grams of water. That's just pointing that out. Okay, at 40 degrees, that's down here, how much solid will not go into solution? So what you have to do is look at 40 degrees for KNO3 and say, well, how much will dissolve? And that's about 60. Okay, so at 40 degrees, 60 grams will dissolve. And they're telling you that they're going to put 150 in. So how much will not dissolve? You would go 150 minus 60 equals 90 grams of KNO3. And that would just all fall to the bottom. Number 8, if 100 grams of water is saturated with KNO3 and it's cooled from 80 to 60, how much is going to crystallize? So we're going to use these two numbers, 80 and 60 on the graph. And at 80 degrees, if you ride that line up, you see that, just to make it easy, I'm going to say it's 170. At 60, when I ride this line up, I'm going to hit right about there, and that's about 105. Okay, so as we cool it from the 80 degrees down to the 60 degrees, what's going to happen? Some of that's going to fall back or crystallize out. So 170 minus 105 would equal 65 grams of KNO3 would go back into a crystal because you're dropping the temperature. How much KNO3 is needed to saturate 50 grams of water? Now here's the change. Most times we're using 100 grams of water. This one is going to use 50. So we've got two things that we know. This chart is for 100 grams of water. And we know that we're talking at 35 degrees. So if we're looking at 100 grams of water and 35 degrees for KNO3, 35 is going to be, let me change my color here. I'm going to do green. 35 is right about here. Go up to the KNO3. That's about 55 grams that would dissolve. Okay, so then what you do is you put your waters on the bottom and you set up a proportion. The first one is the one we always know. It's 100 grams of water. And you just told me that 55 grams of KNO3 will dissolve. So now they're wanting to know at that temperature if it was only 50 grams of water, well then how much KNO3 would dissolve. And this is a cross multiplication and division. You go 50 times 55 and divide that by 100 to get back to x. And x should equal 27.5. The other way of looking at that is saying, okay, we cut the water in half, you're just going to cut the KNO3 in half as well. So if you can see that ratio, they're not always going to be, you know, just cutting them in half, so it won't always be that easy. But that's KNO3. Now, 321 grams of KNO3 are used to saturate water at 60 degrees. What is the mass of the water used? So they are giving you the solute. Water is still the solvent, which goes in the bottom, because remember, solute goes into solvent. So we put 321 grams of KNO3 in who knows how much water. That's our X, because that's the question. And then, what's another number that we know? We know 100 grams of water. So at 60 degrees for KNO3, remember this chart is only for 100 grams of water. When you go to 60 degrees and you ride that line up, that was about 105. So 105 grams of KNO3 will dissolve in 100 grams. All of a sudden, they're going to put 321 grams in. And so the question is, well, then how much water is going to be needed to dissolve that? So again, this is cross multiplication. Wherever you have numbers that are kitty corner from each other, that's your multiplication. And then you divide by the other one to get back to x. So x equals, I've done this a few times. I actually recorded this lecture yesterday for 20 some minutes and it did not work. Let's see, if you use your calculator, we go 321 times 100. Hit equals, because you know I like the equals button. And then divide that number by 105. that comes out to 305.7 grams of water. Okay, so which of the substances on the graph shows the smallest increase in solubility over the range from 60 to 80? And if we look up at the graph and we're looking from 60 to 80 degrees, oops, you're really looking at the slope of the red, looks like that. The green looks like this. And sodium chloride's down there in the blue line looking pretty darn straight. So the one with the smallest slope is going to have the smallest increase of solubility. Okay, I'm going to cut this lecture here and then I will post the next 2 pages in a separate lecture just so they're shorter. Uploads.